Hello, everybody. I come to you today virtually from the state of Michigan in the United States and would like to talk to you about how to spend less time securing our critical information technology infrastructure and to be able to spend more time generating revenue and increasing our productivity in the operational technology space. First thing I'd like to propose are just a few informational technology type questions here. So if I were to ask you who's responsible for the OT security strategy in your facility, would you be able to answer that? Would you know who to ask? As we start to expand our security teams, how do we remain competitive in hiring? How do we make sure that we have the right resources to secure those facilities? And especially as we go through our digital transformation initiatives. And last but not least, do we know where we're going? We have the right resources to properly manage all of those OT security assets. Really, why are those questions important? We're going to dive further into that as we go through our presentation today. But let's kind of dive into the numbers here of really why these are so important. Manufacturing and production industries pay a much higher ransom than any other industry in the world, actually the highest of all. On average, when there is a infrastructure or security breach, the recovery of data costs upwards of $2 million on average for each incident of a security breach. Organizations themselves tell us that 71% are short on security resources. And then even worse, 80% of those organizations are having a hard time finding the right security professionals to fill those roles. Again, and then last but not least, we've understood that 65% of the skills that are needed for manufacturing are changing faster than the skilled workforce. So how do we address all of this? And how do we position ourselves to be in a good place when it comes to security in our OT space? That'll really be the topic of today's conversation. My name is Nick Putman. I'm the product manager for ThinManager, and I appreciate you spending some time with us today. What we'll do is we're going to walk through kind of some of the security posture of the industrial space just in general. We're then going to give an introduction to the ThinManager platform and talk about how ThinManager can help reduce risk. And then at risk of spending too much time on PowerPoint or slides, we'll spend about half of our time together today doing a live demonstration. So what are some of those key driving factors behind a digital transformation and the initiatives themselves? So as we embrace digital transformation and connect our enterprises, that means connecting infrastructures. It means enhancing our operational functionality. We're bringing centralized control rooms into the picture. We're introducing additional remote access capabilities. This was really springboarded through the COVID pandemic with the coronavirus, many people being displaced from their typical working environments. We were kind of forced into remote operations and remote connectivity. It also means we're centralizing more of our authentication, relying on information technology teams to provide access via Active Directory and other technologies, even leveraging additional authentication devices such as biometrics, cards, fingerprints, etc. Again, with this growing increase of remote connectivity, of centralization, there's a lot of risk at play as well, right? And so what are some of those security challenges that we face when we present digital transformation to our architectures, right? So we start to lose visibility to the totality of the asset inventory that we have in our facilities. What are all of the different devices? What are all the various operating systems and firmware versions that those devices are running? We've seen that not all of our customers have properly funded their security programs to make sure that they're properly secured, right? There's unpatched legacy systems. Those systems are oftentimes designed for uptime and productivity rather than designed with security at the core. That oftentimes also leads to a lack of network segmentation. So flat networks become more challenging to manage. And then there's also just a general gap in our IT and OT network ownership, right? If we kind of think about that very first question I own, who really owns the OT security policy? Oftentimes the answer is our information technology teams, but only to a certain extent. So how can we work together better to manage this in a way that works for our productivity and works for our bottom line? Before we move on, just a couple quick examples of what can happen when this goes wrong. An example here from a customer from Mondelez. We see that Mondelez was hit with the WannaCry virus in 2017, and from public records, see that they incurred upwards of $90 million, in incurred expenses due to that breach. right? So just a simple example of how costly it can be when you don't properly have a OT security strategy in place. What are some of those common security attacks that we might see out in the field, in the real world, right? There's all kinds of different ones that we can talk about. Some are malicious intent by employees, others are malicious intent by private organizations or even nation states, and come in effect or in the form factor of spyware, of worms, of viruses, ransomware, or again, and sometimes just user bad intent. I'm not going to go through all of these, but just to give you an idea of how real this really is, these are industrial control system focused campaigns or attacks that are very specific to our industrial sector, right? So these aren't generically targeting Windows devices of any industry. These are all attacks that were curated very specifically to target the industrial control space. So what do we do with that, right? How are we going to present or prevent these security breaches? There's a couple common ways that I think many of us could agree upon to go about preventing data loss, reducing the risk of a security breach, right? That includes restricting access to information, backing up our system, backing up our data, backing up our servers, limiting the access to removable devices, such as USB access on different machines, right? We want to secure our data with passwords. We want to have granular permission to access certain information. We may have password retention policies set forth by our organizations, right? And the list goes on and on. So I think from a high level, we could probably agree that these are all great practices to increase the overall security posture of our environment. But how do we really go about achieving some of those? Well, this is what I'd like to talk to you about today, and it's really how ThinManager can help reduce the risk of security. We'll talk about how to increase your potential for patching and updating all of the different operating systems that you have and identifying where those are. We want to talk about removing legacy software, operating systems, and hardware vulnerabilities from our architecture. Talk about how we can support network segmentation, and then we're going to do all of this while reducing downtime in our environments. So we'll take a look at a lot of this and kind of dive deeper into some of those topics. Some of them will also come up in our demonstration. So I'll pivot now and give an introduction to the ThinManager platform. There's really two key things that I see as being what ThinManager offers. First and foremost, ThinManager is a secure and centralized device management platform. Now, when I talk about device management, I'm really talking about managing the actual operator interfaces that our production employees and engineers leverage to perform their day-to-day tasks, right? So those may be physical terminals that have a monitor connected up to them. In my camera, you will see that there are a few monitors that are connected to thin clients that sit on the shelf behind me. Those thin clients, or true zero clients in our case, are the types of devices that I will talk about centrally managing. And I'll get more into what I mean when I talk about centralized management. On the screen itself is the second critical piece of what ThinManager is as a platform, and that's a centralized content delivery platform. What that really means is we can aggregate content or applications such as Windows desktops, Windows applications, web-based applications, IP camera streams, or even VNC sessions coming from panel-type hardware, all into one centralized location. We bring that into ThinManager by identifying where those assets are in our network. And then we can deliver all of that information out in 4 unique ways. We can deliver that to a device using the MAC address, to a user using the user's name or user group, right? I don't have a MAC address, but I do have a username that exists in Active Directory. Additionally, we can deliver content to a physical location. So on our mobile devices, you'll be able to physically move around, scan a QR code, come within range of a Bluetooth beacon, even using GPS, deliver a unique experience of some of that content we mentioned. And then last but not least, on a particular event, right? Imagine that a light curtain is broken, a tag goes high in your controller, and you want to change the experience that you have in a control room, for example. So all of this together is bringing the right information to the right people at the right place at the right time. If we look at a traditional automation network, they're a lot of work, right? The traditional PC-based approach to plant floor architecture requires us to install operating systems, applications, likely an antivirus software. There's moving parts, right? So there's spinning drives, there's fans for cooling, and then there's even USB access. And I don't have to manage that at just one workstation. I have to manage that at every single workstation and engineering and operating that I have across my architecture. What we're going to propose with ThinManager is a thin client server architecture where we centralize applications, operating systems, antivirus software into one location. And I'm not proposing that this is a new concept, but what will be unique to ThinManager is that instead of leveraging a device that has a local operating system, we will make ThinManager the operating system of the plant floor. Talk about how we'll do that in just a moment. What else does ThinManager provide for us? It also gives us an opportunity to increase our workforce productivity. You'll see on the left, for a control room type layout, we can aggregate multiple different types of content onto one pane of glass. We can control multiple different monitors, and we can do this all centrally. So it gives us a great way to distribute and manage all of the applications that a particular user might need to be able to facilitate their day-to-day actions. The extension of mobility also allows us to have that same operator interface and experience that you see on a physical wired terminal on a mobile device, and even allows us to do simple things like pop open the camera, scan a QR code, and change the experience that we're seeing on that mobile device. Right? So really providing all of our operations and engineering the right information at the right place at the right time. ThinManager allows us to reduce our unexpected downtime. There are kind of three key ways that do this. Most applications by themselves do not offer highly available client-side options. ThinManager will allow for configuration of what we can call failover, so that if an application server hosting say a SCADA or an MES application either needs to be taken offline for planned maintenance or becomes unavailable unexpectedly, ThinManager can automatically deliver content from another location in our infrastructure. If one of the actual thin client pieces of hardware were to fail, we are able to reduce that or to replace that hardware in under 2 minutes. Again, with nothing living on these zero client devices and all being centrally managed, it takes very little information and very little training to be able to replace physical failed end workstation device hardware. And then last but not least would be redundancy in the ThinManager server component, right? Providing a high availability of the database and the server that provides all of the information required to deliver firmware and content to one of the terminals that we will get into here in just a few moments. So let's look more specifically at how ThinManager can help reduce some of those security risks, right? So first and foremost, we're going to reduce the overall attack surface. If you think back to the architecture slide I showed just a few minutes ago, right? We talked about eliminating the Windows operating systems that used to be deployed to all of our engineering and operator workstations and replacing those with ThinManager. The way that this is done is it's done by delivering a lightweight firmware from the centralized ThinManager server over the network, and that lightweight Linux kernel gets unpackaged into the RAM or into the memory of the device. The devices that ThinManager manages do not leverage a hard drive. You do not even have to have a hard drive in the slot of that particular piece of hardware. Right, so we're talking about an extremely lightweight operating system that's not built on top of a hard drive, distributed over the network, and runs as the smallest possible Linux kernel on that device as the operating system. Further, ThinManager can introduce and leverage Docker container technology to actually host lightweight applications on a thin client itself. You may be wondering why I have a game sitting over my shoulder here. I have a game of solitaire. We'll talk about that during my demo, but that's being hosted in a Docker container running locally to a thin client. So there's no operating system that's local to any device, nothing installed anywhere to be able to host this application, showing the flexibility of the platform. Right? And then last but not least here on reducing our attack surface, even if that hardware does happen to have USB ports, which are going to be required for interaction for peripheral devices, you won't be able to bring external storage devices. If there's a CD drive, a DVD drive, or even a physically installed hard drive into the device, there will be no access to that physical storage, right? So we completely restrict that by default. Again, just kind of looking across that server client architecture, where we're really going to focus our conversation today and in the demo are going to be kind of in the red box that's highlighted for you. This is going to be those end device terminals, the ones that I have sitting on the shelf, the ones connected to the monitor, and the ones that are either connecting to a centralized resource to display an application, such as a SCADA or an MES application, a Windows desktop, a web application, or even hosting some of those web applications or custom applications in those Docker containers. Right, we'll be completely securing that architecture. Again, how does the Docker container help us secure our infrastructure? It helps us by reducing the overall need to deploy Windows-based systems, or any operating system for that matter, to host a bunch of web browsers to deliver applications out to zero client devices. What we'll be able to do, again, is run a very lightweight Linux-based web browser on a device in the RAM disk or in the memory of that device with no local operating system, eliminating a lot of management from both IT and our operational technologies. On the topic of centralizing our applications, right, we can really start to take advantage of that install once, manage many paradigm. Meaning if I have a handful, let's say a dozen different workstations that across my facility that all need to connect to the same centralized SCADA server, instead of delivering or installing a bunch of Windows operating systems and having those operating systems then host the local client, we'll be able to actually connect to a centralized server. And when I need to update that system, I need to make one update to my centralized server or my redundant pair to be able to update all of the different client-side applications. It makes this a much more manageable system for our maintenance teams to be able to deliver maintenance on. Above and beyond that, we're using a very low port count to be able to deliver this. So whether we're making an RDP connection that's encrypted and negotiated over TLS, or we're connecting out to a web server, we're doing this using a very small number of ports, and we can lock down our networks pretty tightly when leveraging ThinManager. We mentioned some of the challenges early on with network segmentation as well, right? So ThinManager does fully support deployments across multiple different layers of the network. We have a couple great examples that I'll leave you with for how to deploy ThinManager in an IDMZ, whether or not you want to have ThinManager located on the industrial side, the enterprise side of your IDMZ, or even inside the IDMZ to facilitate information from your plant floor network securely up and into the enterprise. And then last but not least, there's a lot of other ways that we bring in centralized access control. So we talked about centralized authentication, leveraging of Active Directory. There is also restricting access to the full desktop experience and delivering only the application that you need. We can also bring in some level of multiple forms of authentication, something that you have, something that you know. You could have a password, you could have biometrics like your fingerprints. You could leverage the badge readers if you wear a badge at work, all kinds of different capabilities there. And then as well as putting granular permissions on the ThinManager software itself. So you'll see a lot of the capabilities that ThinManager has. We're able to granularly decide how and who will have access to ThinManager for what parts of configuration and what different tasks they may need to achieve. For the centralized authentication login, I mentioned some of the different types of authentication devices that we use there, right? We're allowing badge readers, we're allowing biometrics. We have a partner that we work with that does wearable support. It looks very much like my smartwatch here, and it allows me to authenticate myself on the device. That's a device called NIMI. So a whole different suite of capabilities to allow centralized authentication and to standardize the way that people access not just one, but all of the different applications that they interact with. We can leverage ThinManager to be that centralized authentication provider for all of those applications. So with that, I'd like to move forward and do a little bit of a product demonstration on some of the security capabilities that the product offers today. So I'll switch gears here just a little bit, and I'm going to pivot to a few virtual machines that I have powered on and ready to use for our demo today. What you'll notice is that I've got a Windows operating system here. This is a Windows Server OS. It doesn't necessarily have to be, but I'm going to co-locate both ThinManager, remote desktop services and my client-side applications that I would like to deliver. I'll go ahead and make ThinManager a little bit bigger. And before I make this full screen, I'll point out that we have a handful of different virtual machines that I'll leverage today, in addition to the physical clients that are sitting in the home office here with me. One of the first ways that you can really think about ThinManager is building that system. If we were to think all the way back to that architecture slide that we looked at, talking about the content that I had on the left side of the screen, the Windows applications, the Windows desktops, the web-based content, IP cameras. First thing we're going to do is we're going to tell ThinManager where all of that lives. So what we do is we create what we call display servers. I won't walk through this all in detail, but it is fairly straightforward. We identify for ThinManager where are all of the different display servers that we're leveraging. What is the IP address? What's the name of those servers? Right? You'll see here I've got multiple in a system. You can bring as many of these as you would like in, and these are going to be the hosts of different applications. The display client is really where I start to define what is it that I want to look at. So if the display server is the where, the display client is the what, and the what is, do I want a full desktop experience? Do I want just a particular application? Do I want just that particular application and a specific client file to be opened in that application? And then how do I want to deliver all those? Right, so we'll go through the process of identifying all of the different locations in our architecture that applications already live. We'll define the applications that are needed for production, and then we're going to work on delivering those out to the 4 unique mechanisms that we talked about, to the different devices, to the different users, to the locations, and by event. We're going to focus first on by device. So I'm going to select a terminal. You'll see here I have a whole bunch of different terminals that are configured. Think of a terminal as a physical device. It's going to be the device itself that has the monitor or the pane of glass that provides us visualization. It's probably going to have a mouse, a keyboard, and it's going to be that workstation that our engineering and operations maintenance staff interacts with our production facility. Right? It's that window into our production. The next thing that we'll do is we'll configure for one of those devices what is the application that we want to look at. You'll see here I've got the terminal for Lester configured to have a single desktop display client. What that means is when we bring up that device, it's going to receive a desktop. So I have a handful of the clients behind me. Because it would be difficult to see the firmware load on the small camera view, I'm going to leverage a virtual thin client. It's the exact same process, the same set of technology stack that's used for any type of client. We make a request out over the network by powering the device on, something that is standard on any Intel-based chip. And it said, is there anybody out there that can request or can reply to a PXE or UEFI request? ThinManager acknowledges that request and delivers the ThinManager firmware. That was that very quick yellow loading bar you saw. What's happening now is we've received that roughly 10 or 11 megabyte payload, the ThinManager operating system over the network, and we're going to unpackage that into the running memory of the device. It's then going to request to ThinManager and say, okay, I'm now running the ThinManager firmware as my operating system on the local Thin client. Do I have a terminal profile that's configured in the ThinManager server? Because we've configured this device, ThinManager's replied yes. It said, I have a profile for you. And that profile is to deliver a desktop from a centralized server. So what we now have is we have a desktop running on what is essentially a virtual version of one of the Thin client pieces of hardware that I have on the wall here. So that's kind of the boot process and how that works. We're able to boot all of the different terminals like that. Should one of the pieces of hardware here fail, I simply replace that hardware. And when that device comes up the next time, I'm going to have a slightly different experience. To simulate what that looks like here in a remote environment, what I can do is I can manipulate this existing terminal that we just booted, and I'm going to go ahead and remove the MAC address. That's the physical address of the device, and that's how we bind the terminal profile that you see in the product to the experience that we want to deliver to the operator. This time when I power on that same virtual machine, there will be no connection. ThinManager has essentially never seen this physical, or in this case, a virtual device before, so we'll deliver that firmware package just as we had before, based on some standard network technology, right? PXE or UEFI. will then unpackage that firmware package into the running memory of the device. And about 2/3 of the way through the boot process, it'll say, "Hey, ThinManager, do you have a profile that matches the MAC address of this device?" And in this case, it says, "No, I don't." So what I would like to do then, if I'm the operator, all I need to be able to do to replace failed thin client hardware is I just need to know the physical name of the workstation that I happen to be working at. So I'll navigate into my group. I can only replace terminals that are powered off. So if I only had one failed terminal, I'd only have one choice in the list. This makes this very straightforward. Obviously, I have quite a few of them at this point that are not currently powered on. I'll select my terminal profile. If I were to look back at my ThinManager server, I'll see that that terminal is booting up. It's receiving its configuration. And once it does, it'll establish that desktop connection out to the host that we've identified as the one that can deliver that information. So if I look here, I can now see I have that desktop being delivered. I can move the mouse and keyboard just as I would if I was standing in front of one of my physical clients. And one of the great ways to see the power of centralized device management is that I can come to any one of these powered on thin clients and I can shadow that thin client itself. Because I'm sitting as an administrator and I've given myself administrative privilege, I also have the capability to have what we call interactive shadowing. So I could actually help that operator, right? So if I were to look at my the system connected to the wall behind me, I could come and also shadow any one of the thin clients that we have on the wall. I have a particular thin client with a SCADA running. I have another thin client hosting a pair of different containers. And again, I have given myself interactive capabilities to be able to shadow this, which gives me the ability to actually drive the interactions on those different applications, change displays, and help the operator if they were 50, 100 meters across the plant, right? So again, giving myself centralized visualization, centralized control of not only the content itself, but we're also now taking ownership of the hardware. ThinManager is the operating system that's running on these devices. They just happen to be making remote connections out to a centralized server. So we'll kind of continue this. I've only delivered a desktop so far, right? But let's say I didn't, the operations team that works at this location doesn't need the full desktop experience. We don't need them getting out into the file explorer, perusing the network, launching other applications. All they need is an HMI application. I'm kind of working quickly here through my wizard, but I could deliver a single application to the terminal. What I would do is a right click and I'm going to do a restart of the terminal. You'll notice this isn't going to re-deliver the firmware. The device itself, or in this case, the virtual device, already has that operating system running, the ThinManager OS. It just needs a new configuration. So we're going to go ahead and initiate a terminal restart. It's going to receive a new configuration, and it's going to deliver the new application or the new experience that we've configured for that particular piece of hardware. So again, whether it's here in the physical device, or in this case, the virtual device, or on the shadow itself, I can come back and see the new experience that I have. And in this case, I only have this, in this case, the InTouch application running. There is no full desktop behind this. I could pound on the start menu. I'm not going to get, or the Windows key, I'm not going to get a start menu. I can't get out to the file explorer. I'm delivering only this application. If the application were to be closed, it would the watchdog in the background would just restart this application, right? So I'm delivering only the capabilities that are actually required for this particular workstation to perform those tasks. If I wanted multiple applications, I could simply start augmenting the additional applications onto the screen. Maybe I wanted to add the desktop and the design time environment all into the same thin clients. Again, just adding additional what we call display clients, or the what is it that I want to look at. Even if they're coming from the same host application server, I'm doing that right click and restart my terminal again. And this again gives me the ability to now deliver multiple pieces of information to one pane of glass, just like we're doing above us and now on the screen itself, right? So that physical, or again, virtual thin client here is getting a new profile. We're doing this from a centralized location, and we're going to experience what we call tiling. Tiling is going to be the delivery of multiple different applications to the same pane of glass. It's a handful of different ways that I can interact with this. Call this multi-session. I could interact with these sessions as they are in the tiles, or if I feel that that's too small, I could make any one of these full screen, and I can set this up with multiple different mouse clicks, with shortcuts, with hotkeys on the keyboard. A very configurable experience for us to leverage our interaction with the different applications. So again, I could navigate between them, or I could simply use the display client selector at the top to select which one is unique. So far, all we've done is deliver content to a device. I'd like to briefly, before we move on, look at how to deliver content to a user, or to kind of augment that experience with based on who I am. If I click on my users tree here, you'll see that I have a handful of users brought into the environment. This has been done connecting Active Directory users into the system. And so these Active Directory users at the group level have been assigned additional applications. So let's say I have one of these thin client terminals that sits out on the production floor, and maybe there's only a single application running, or in this case, I now have 3, and I wanted to log in as a particular user. I could come to the main menu, and I can get here with hotkeys as well. I'm going to do a login, and this is where I'm going to log in with my Active Directory user. So I'm going to go ahead and log in as a particular user, and I'm going to get a unique experience based on that user. In this case, I see that I've logged in as a user named Matt. That user happens to be a member of the maintenance team, and anybody in the maintenance team is going to get the maintenance work order system. So now notice, I didn't lose the content that was tied to the physical device. I just added additional content that's associated to me as the user. Furthermore, the InTouch application can be automatically logged in as Matt. So if there's additional permissions that Matt has in this application, Matt would have those permissions would be automatically inherited. Matt doesn't have to go around and log into each application independently. So not only productivity enhancing, but also we're making sure that the right user is always logged in to the right application when they're at that device. There is full audit and traceability to all of the different logins. It'll even tell us how Matt logged in. In this case, Matt logged in with a username. I had Matt's password cached, so that's why you didn't see me require a password for Matt. But that's absolutely something that can be required. I'm going to go ahead and switch users. And in this case, maybe I want to log in as an operator. I'm going to log in as Otto. I've asked Otto to say, hey, Otto, I don't require you to type in your full 80 password. I'll cache it, but I do want you to use a 4-number PIN. Shadowing that on the screen for you, I just put the year 2023 in, and that's going to allow me to log in Otto. Otto's going to get even a different experience based on who Otto is. There's going to be some additional documentation that Otto has when Otto logs into that terminal. On inactivity, the user would automatically be logged out. That's a configurable amount of time. I could come to my main menu. I could log off and return the information to just those that were originally delivered to the thin client itself. Right. So we've been looking at the different applications here that are delivered to the device. Do also want to take a quick look at those containers that we talked about a bit earlier. The containers themselves don't have to be connected to a remote desktop server, right? So when we talk about the desktop, or the in this case the Aviva Studio, I'm seeing here that this is running on a remote desktop server. I can see here that there are multiple different sessions. So these are remote sessions established on a Windows instance. I have this other thin client running, and I'm going to go shadow that one now from my from ThinManager. This one's named Artemis in the Space Programs group, and this happens to be running a container. In this case, the container is hosting Solitaire. More useful might be to deliver something like an instance of Google Chrome or Firefox as a web browser locally to that device. But what I'd like to point out is that this is running locally on a device with absolutely no hard drive. So at the same time that I would have delivered the ThinManager firmware and all of the different drivers and modules that allow me to interact with the system, I've now delivered a container instance. Notice instead of having a Windows session, I will see here that there is a container that's running on that device. I could augment this with multiple containers. They could be multiple different applications running on the device. To bring in one of the containers that is provided by the ThinManager team, you could install the Chrome, Firefox, or Citrix augmented Chrome or Firefox web browsers into the ThinManager system, and then I could allow those to be delivered to any one of my thin clients. I've also kind of compiled a custom container here that has the Solitaire game engine, and I've installed that. So all I need to do to deliver these various applications to those devices is to select, as I walk through my Thin client terminal, which one of those container applications do I really want to be delivered. I could add Chrome, in this case, which has already been added as a container instance. Again, like anything, I can restart my instance and deliver that application out to the Thin client, right? So we'll initiate a terminal restart, just like we always would, deliver the additional container image to the device, and we'll see those container images now hosting applications without Windows, without having to install remote desktop services, client access licensing, and all of the overhead management that goes into delivering web-based applications. We can now simplify that architecture and collapse that down to simply having localized container applications running on a Thin client, making a connection directly to the web server and hosting all of the visualization that we need for those web-based instances. So with that, I'd like to kind of close our conversation for today. I really hope that you found some of this to be helpful and insightful, and hopefully you see the power that ThinManager brings as it comes to helping you secure your information technology managed assets, but also empowering your OT teams to be able to get back to working on productivity and working on the bottom line. In closing, I'd ask that you take a moment to play with the product if you have the opportunity. You can create a 30-day demo code. I'll leave the link here. It's on thinmanager.com. Feel free to also reach out to myself and our pre-sales engineering team. We are more than happy to do a live demo for you, more than happy to talk through any architecture questions that you might have or help you understand if ThinManager is a good fit. You can reach us at services@thinmanager.com. And I appreciate your time and really thank you again for watching today's presentation. Have a good one.